What is a complex fraction?
A fraction is complex.
Brent?
Something that has multiple operations.
Well, it's kind of similar to that. That's closer than this, what we call the, Captain Obvious answer up here. Yes.
Like a mixed number fraction?
It's similar to that. The definition of a complex fraction, here's some important concepts. Complex fractions are fractions within fractions. So if you like, I have a fraction that has a fraction in it. Here's an example of a complex fraction. Something like 2/3 over 1/5. It's a fraction within a fraction. The ones that we're going to be dealing with are going to have x's involved. So there'll be fractions like x plus 1 over 7 with x plus 1 over x in the bottom. Things like that. Now that looks pretty complex, right? A complex fraction is a fraction within a fraction. One way to simplify them is to combine terms in the numerator and denominator and then divide, right? We know how to divide fractions. How do you divide fractions? You multiply by the reciprocal. To divide fractions, we multiply by the reciprocal. You keep the top, you flip the bottom, and you change division to multiplication. You keep, flip, and change. All right, so let's just dive right in and look at some examples. A over x over, or divided by, b over a plus x. How many terms do we have in the numerator? One term. How many terms are in the denominator?
2. 1.
One term. The fraction bar is a grouping symbol, so this is one thing divided by one thing. And so I'm going to write this as a over x divided by b over a plus x, which is the same as a over x times a plus x over b. And how do you multiply fractions? Top times top, bottom times bottom. So a times a plus x is a squared plus ax over bx. At this stage right here, because we're multiplying, you could cross-cancel any common factors that you had, but we don't have any common factors between numerators and denominators. So that is the simplified version of this complex fraction. Your goal when you're simplifying complex fractions is to make sure you don't have any complex fractions in the end. This is not a complex fraction. It's just one fraction. It's not a fraction within a fraction. Okay? Next example is similar to that one. We just have one term divided by one term. Just so happens that both of the terms are fractions. So I'm going to do exactly what I just did, and I'm going to rewrite this as a division problem. AM over N divided by X over MN. And to divide by a fraction, we do what? You multiply it by its reciprocal. And here is a perfect example of where we're multiplying and we can cross-cancel factors. Is the n a factor of the numerator? Yes. Is it a factor of the denominator? Yes. So we can cancel the n's, and we are left with am squared over x. How do we know we're finished? No complex fractions, and nothing else can cancel. We don't have any other factors that can cancel out. Our fractions are reduced, and there's no complex fractions left. All right. Now, what if we're looking at one that's a little bit more complicated? Can we go ahead and skip the step that involves showing the division?
Yeah.
And just show this as 3x over 6x plus 12. times x plus 2 over 9. Now, because we're going to have to simplify these things, doesn't it make sense to look for common factors at this point?
Yes.
Now, how do we look for common factors? By doing what? By factoring. Is there any expression here that can be factored?
6x plus 12.
6x plus 12 can be factored as 6 times x plus 2, and that's great because I can see now that I have some common factors that can cancel, right? I can cancel the x plus 2's. And what else can cancel?
The 3 and the 9.
3 and the 6 or the 3 and the 9. It doesn't matter. It can cancel with either one. So if I cancel there, I'm left with x over 18. All we're doing, it's a very dissatisfying thing. This is one of those skills practice. Practice simplifying these complex fractions. We're not coming up with an answer. We're just changing something from one form to another form. So it's one of those things in algebra that you kind of like, why are we doing this? Well, the reason you're doing this is because you're learning a skill that's going to be necessary to solve rational equations in the future. A whole lot of trigonometry use complex fractions and simplifying complex fractions. So there's a lot of applications to this skill in the higher mathematics. Brent?
If you have like numbers instead of variables, wouldn't it just be easier to divide all of them?
Yes, if you had numbers instead of variables, it would be easier. But that's not what we have here, unfortunately. And you could also start at the very beginning and simplify things, factor things, but we're going to be factoring to simplify. Now here's a little bit more difficult. What you got? What else?
Like put in parentheses like 3x divided by 6x plus 12 in parentheses, and then divided by 9 divided by x plus 2 equals 2.
So just write it as a division problem from the beginning? Yeah, you can do that. But this one is going to be complicated. Why is this one different from the previous examples?
Because the bottom one's a fraction.
The bottom one isn't a fraction. It has a fraction in it. Well, what's really the problem?
It has it's gonna have a complex fraction when you start multiplying or.
This is one thing divided by how many things? Two things. Right? The first three examples, one term divided by one term. And if you're dividing one thing by another thing, then you can multiply by the reciprocal, right? Multiply by the reciprocal. What's the reciprocal of two things? Well, you can't reciprocate two things. You have to combine the bottom terms by getting a common denominator. And when you combine the bottom terms by getting a common denominator, then we'll have one thing over one thing, and it's back to the same game as the first three examples. All right, so what is the common denominator between 1 and 1 over x?
Couldn't the what
Answer, hold on. What's the question? I just asked the question. What is a common denominator between 1 and 1 over x? X. Right? So I'm going to write 1 as x over x. Just got to get a common denominator. So I'm going to multiply this. Just if I was adding 1 minus 1/2. The common denominator is what? 2. So that's 2 over 2 minus 1 over 2, which is 1 over 2. Now you can combine them once you have a common denominator. All right? Now I can rewrite this as 1 over x divided by x minus 1 over x. I'm not writing. This is not intuitive. I'm going to show you another way to do this in just a minute. No, you cannot, because they are terms. You can't cancel terms. You can only cancel things that are being multiplied. You cannot cancel in that original problem. You cannot cancel the 1 over x's because the 1 over x in the bottom is a term. Okay, now 1 over x divided by that is the same as 1 over x times x over x minus 1. And that gives us what?
1 over x minus 1.
1 over x minus 1. Now, it's not intuitive from the very beginning that those two things would be equal, that our original expression here would equal what we end up with in the bottom.
And you can't cancel the ones.
You can't cancel ones. No, because that 1 in the bottom right here is a term. It's not a factor. It's not being multiplied by anything. It has to be being multiplied by everything in the bottom in order to be a factor.
Say it
It's
was
not.
x times 1.
That wouldn't change anything because x times 1 is just, if you cancel the 1s, you're still left with 1x. All right, here's an alternate method of doing this. What is this?
Fraction.
It's a complex fraction. It's a single term, right? What are we allowed to do to terms?
Multiply by 1.
We can multiply them by 1 or we can add 0. That's the only two things that we're allowed to do to this expression. So I could, in the same way that I get rid of fractions in an equation, I can get rid of fractions in this expression by multiplying the top and the bottom by a common denominator of all my fractions. Common denominator of all my fractions here is x. So I can multiply the top by x, and I can multiply the bottom by x. What's 1 over x times x? It's 1, because they're reciprocals of each other. Now, when I multiply here, I have to distribute. What's 1 times x? And again, 1 over x times x is 1. It's a little bit more of a direct path to the correct answer. It gets a little complicated when you're dealing with, lots of denominators and lots of variables. But that's another approach that you can take. What are we allowed to do to terms? We're allowed to multiply by 1. So in the same way that I multiply equations to get rid of fractions, I can multiply the top and bottom of this fraction to get rid of fractions. So you multiply by the common denominator and the fractions are gone. Yes, Wilson?
I'm assuming later we'll be multiplying complex fractions.
No, that's a little more. This skill, you don't ever have to do that. You would simplify your complex fractions before you multiply them. So that's just, yeah. Brent?
How come you do 1 over x times x is 1, but when you do it to the other one, it's x minus 1?
Because you have to distribute this, right? What's 1 times x?
1x.
That's x, right? And then this term times this is 1 again. Because fraction bar is a grouping symbol, so that's a parentheses. So I'm multiplying x times 1 minus 1 over x. That's x. That's 1.
Well, I mean, like, isn't it a reciprocal? So the first one would be 1 and the other one would be... Oh, wait, I got my mistake.
Good? All right, last example. It took Max 3x squared minus 12x over 3x minutes to speed walk to the gym that was 5x minus 20 over x cubed miles away. Find his rate in miles per minute. Now, this looks really complicated, right?
It's a beautiful way to measure minutes.
Yeah. Let's this is a real life application here. It's a failed attempt at a real life application of complex fractions. Trust me, there is, outside of mathematics, there is no real life application of complex fractions. All right. What quantities are we working with here?
Complex fraction.
We're working with speed, right? And rate and distance. Now, I don't know about you guys, but this sounds an awful lot like distance equals rate times time. except they want to know what the rate is. How would you find the rate in this expression? You divide both sides by time, and you get rate equals distance divided by time. So the distance is 5x minus 20 over x cubed. And I'm dividing that by 3x squared minus 12x over 3x. And then this just becomes like example 1 or example 2 or example 3 that we looked at earlier. You divide these two fractions by multiplying by the reciprocal. All right? From there, I'll let you finish it. Homework? Now, some of these problems, guys, as we move into these later units, some of the homework assignments are just going to take a little bit more time. I'm going through and carefully selecting problems that are going to be relevant, but this is not something you would probably be able to do just in a study hall, 50 minutes distracted by your friends. So don't wait to do it that way. You want to make sure that you